Welcome to 2.3, Angle Properties in Triangles. And at the top of your page here, they give you two angle properties that might be helpful in calculating angles or proving that angles might be congruent or equal. So the first angle property they're talking about here says that the measures of the interior angles in a triangle sum to 180 degrees. Sum to 180 just means add to 180 degrees. And so it says angle A plus angle B plus angle C equals 180 degrees. And over here, they've labeled angle A, angle B, and angle C. So you might remember from grade 8 or even earlier that all the angles in a triangle have to add up to 180 degrees. And that can be helpful if you were given some angles and you need to calculate others. The second property says that the measure of an exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to the exterior angle. Okay, and then they've got some angles down here. So let's go through those. So it talks about, first of all, angle DBA. And angle DBA is labeled right here. They've got this little half circle going on here. So why is it called angle DBA? Why not just angle B? Well, the reason why it's labeled angle DBA, get my pen here, is because we've got an angle B here, but we also have an angle B on the inside. And so you don't know which one you're talking about if you say angle B. So anytime that you're not sure if there's a possibility that it might be more than one angle, you have to label it according to the way it's been created. So when it says angle DBA, it means we started at D, we moved to B, and then we went up to A, and the angle created by that motion. So that's where angle DBA comes from, and that's why they call it that. Let's get rid of that. So there's angle DBA. Okay, and they're saying that angle DBA is the same or equal to angle BAC plus angle CAB. Angle BAC, moving from B to A to C, creates this angle. That's angle BAC. And angle ACB, moving from A through C to B, that's ACB. So it says that the yellow angle, DBA, is the same as adding angle A and angle C. Well, why would that be? Well, think about it though, because right here, this angle here, the other angle B, angle ABC, if you add this one and this one, you have to get 180 degrees. It's half a circle, or we call them supplementary. So if I add this angle and this angle, I get 180. Well, keep in mind as well that this angle, ABC, or this red angle here, plus this angle have to add to 180 because they're interior angles of a triangle. So if these two add to 180, and these two plus this one add to 180, this exterior angle has to be the same as these two interior that are not next to that angle. Okay? So if you can remember that, it might be handy. It might come in handy sometime to be able to prove angles or to be able to come up with angle measures. Okay, so let's move on to example 1, and it says determine the measures of angle ABC. And here they haven't labeled the triangles, they've just labeled the angles, which actually makes it a lot easier. Okay, so I think angle C is the easiest to start with because hopefully you remember that these three angles here are half a circle or supplementary, and because they are that, they have to add to 180 degrees. So we could say that 50 plus 65 and angle C has to add to 180. 50 and 65 make 115. Okay, so what do we have to add to 115 to get 180? Well, we can do that by subtracting 115 from both sides. So we can get C is 65 degrees. Okay. Let's put that in red. Let's get rid of this. So angle C is 65. Sometimes it's handy to write that in. All right, now what about this line here? Look at how it has this arrow here. This line and this line right here, both have these arrows. Remember, that means that they're parallel, okay? So sometimes it's really handy when you see parallel lines, get out a highlighter and highlight them, okay? Because highlighting them, hopefully now you can see a backward Z or an S. And so we can use our rule. The rule is angles on either side of a transversal from parallel lines. So two parallel lines cut by a transversal. Well, we can either create, alternate angles here. So angles on either side of the transversal. So if this is 65, so is A. So right away we can just say that A is 65 degrees because they're on either side of the transversal. And if A is 65 degrees and C is 65, B is whatever's left over. So A plus B plus C have to make 180 degrees because they are the interior angles of a triangle. A is 65, B we don't know, C is 65, 65 and 65 make 130. So if we subtract 130 from both sides, we get B is 50 degrees. Okay, that's example 1. So example number 2 is a little harder because we have to prove. It's not asking you to calculate an angle measure, it's asking you to prove something. And here it's asking you to prove that angle ACB is equal to angle ADE. And lots of times when you're doing proofs, I find it helpful anyway to label it, okay, to sort of highlight it so that I can see what I'm doing. It's asking to prove that angle ACB right here, that angle, is equal to angle ADE. ADE. It's asking you to prove that the purple is the same as the blue, okay? And when we prove, what we do is create a table. Create a statement and a reason table. Okay, and you're going to get lots of practice at this. So you probably have no idea what I'm doing right now, and that's okay because this is the first time we're doing it. But you're going to do quite a bit of these eventually. Okay, so I want you to put a statement here. And then over here in your book, I want you to write reason. So you're going to make a statement, and then you're going to give a reason why it's true. And that's how we're going to prove. Okay? And I like to start with what you were given, because you can use that. So we were given that AC is equal to AD, and they've shown you that on the triangle with these two little lines here. AC is equal to AD. Okay? Well, think about what that gives us. If this line is equal to that line, it's an isosceles triangle. Okay? Two sides are the same. And if it's an isosceles triangle, then I know that this angle here is the same as that angle because they're opposite equal sides. So let's back up and say, first statement is that AC is equal to AD because we're going to use that, so I want to put it in my proof. Okay, AC is equal to AD. How do we know? They gave it to us. It was given. It's the very first thing they told us. Okay, so AC is equal to AD. It was given in the example. But then what do we know from that? If AC is equal to AD, I know this angle is the same as that. Now I can't call it angle C because I have two angle C's. So I have to call it angle ACD. So we put a little angle ACD is equal to angle ADC. Now you could say that two different ways. You can say that they're equal because it's an isosceles triangle, but because I said that AC is equal to AD, that's the reason why I know that angle ACD is equal to ADC, because, hold on, let me get my pen right, they are opposite equal sides. I like to use that one a lot. Okay, So if this side is the same as that side, this angle across from it is equal to that angle across from it. Because remember, this angle makes this side. This angle makes that side. Okay, so now we know that this angle is the same as that angle. Well, what do we know about this purple angle, ACB, and this interior angle, ACD? What do we know about them? They add to 180 degrees. So I can say that angle ACB plus angle ACD equals 180 degrees because they're supplementary. You can just put sup. Can't I say the same thing on the other side? Can't I say that angle ADE plus angle ACD, sorry, ADC, same thing, they're equal to 280 degrees because they're supplementary. All right, well, if ACB and ACD equals 180, and ADE and ADC equal 180, don't these two equal each other because they both equal 180? So I can say that ACB and angle ACD equals angle ADE and angle, come on, stay with me, pen, ADC, because they are both equal to 180 degrees. I know that's a little messy. Okay, I'm going to use some colors to help you out here. We're almost there. We're almost done. Okay, colors. ACB. Here's ACB. ADE. ADE. Okay. But look it up here. Didn't we prove already? Didn't we prove that ACD equaled ADC? Because they're equal. So can't I take out ACD and write ADC? Because they equal each other, don't they? So I can say that ACB and replace ACD with ADC equals ADE and ADC. Okay, and that's just substitution. I just substituted that angle. Okay, what do I have on both sides? I have an ADC. So if that's the same on both sides, I can cancel them out. Okay, if you add the number 4 to both sides, you haven't changed anything. Those two sides still equal each other. So now I'm down to angle ACB equals angle ADE. And that's what I wanted to prove. ACB equals angle ADE. Okay, so get started on your homework and let me know if I can help you.